Okay, good morning all. Let us begin with or let us continue with the discussion of single linked list. Probably those who have attended my previous class on Monday, I you might have seen I have discussed the manual working of how the insertion of a node happens at the rear end of the list. Okay, today we will see a programming part of it. Okay, we have discussed all the theoretical stuffs up to the previous class. Today we will begin with the coding part. Okay, let's just begin the coding part. Okay, before I proceed, I have you in the previous class that you require what is called as malloc function. Okay, for achieving this creation of the node. Okay, so let us begin. I'm asking you again whether my audio is clear because my video is not working. Whether audio is clear, please let me know. Voice is breaking. How about others? Aryan, your voice is breaking. Oh, let me just stop video. Now my audio is okay. Yes, thank you. Now let us begin with the things. Okay. So in the previous class, I had stopped at this animation. Okay, if you can remember, how do I insert a node at the rear end of the list? Now we will begin with the very primitive thing that is required for implementation of any insert function in a singly linked list. Okay, that function is called as creation of a new node. Okay, just pay attention towards this. Whenever you want to create a new node, I will use this user defined function. Please remember this is user defined function as discussed I think in the previous class. Okay, we had discussed about creation of a node using the malloc function. Fine. So this function, for me, I have created this function with the name create node. You can give your own name, not an issue. And the return type I have written, return type of the function is struct node star. What is the meaning of struct node star? It talks about the address of the first ever byte of the allocated memory location. Okay. Now I'll just go to the coding part of it. Okay, now you just see, I hope this is visible for you guys. Please let me know, is this visible for you? I'll just minimize all these things. Yes, yeah. Now, can anybody quickly tell me what is the size of each node that is getting allocated in terms of number of bytes? Yes, guys? Is it only 2, Praveen? 4. Why? Why it is 4? Can anybody comment why it is 4? Why it cannot be 2? Why it has to be 4? Can anybody comment?
One for info and one for address.
Address. Okay, address is also unsigned int. Unsigned int also takes 2 bytes. Okay, so 2 plus 2 is 4. So every time a node has to be created, that node has to have how many bytes allocated? 4 bytes of memory. Okay, for this example, if this info part changes, obviously the number of bytes allocated will change. Okay, now let me take up the create node function. The create node function has to bother about allocation of 4 bytes. Okay, allocation of 4 bytes, and those 4 bytes have to be intact together, pointed by a single pointer. Okay, guys, please give me 1 minute of time. Let me start the video if I can get the video, because always videos have more effectiveness than only audio. It is according to my knowledge of understanding of any concept whoever is explaining. So I'm just trying for the video connectivity. facial expressions are more important than only your audio. Okay. I'm so sorry, I cannot connect to my video. Okay, anyways, let's go ahead. Now, when I want to create a node, that node must contain two parts in it, one part containing the actual information to be stored and another part containing the address of the next node. Okay, probably this is clear for you. I hope so. This is clear for you. Now, with this background, anytime you want to create a node, you have to allocate those many number of bytes. Okay, what are the different functions of memory allocation? Can you quickly tell me? Can you quickly comment on this? What are the different functions of allocating of memory dynamically? Comment quickly, guys. I'm waiting for your comments. Malloc, alloc, realloc, 100% correct. So among them, I'll be using what is called as malloc. Reason being, it is the simplest out of the three. Okay, realloc is mainly used for already allocated memory you want to enhance or you want to diminish. So among malloc and calloc, I prefer malloc than the calloc because I don't want to specify how many number of nodes at the beginning. I just want to specify at this point in time, I want a memory location for one node. Okay, that's why among the three, I choose what is called as malloc function. I hope this is clear for you. Please comment quickly. Why should I choose malloc? I have explained about that. Whether that is clear for you so that I can proceed ahead. Yes, again, I have to explain. Fine. Among the three, calloc, malloc, realloc is mainly used for increasing the number of bytes already allocated or decreasing the number of bytes that is already allocated. Which one? Realloc. Okay, so realloc's functionality is reallocating previously allocated, or you want to do the changes to the already allocated memory location, then I will use what is called as realloc. The word itself tells that already it is existing, you want to reallot. Okay, so realloc is ruled out. Then comes what is called as calloc and malloc. Among the two, calloc expects two parameters. First parameter talks about how many such things you want to allocate and each unit's size. What is the size of each unit and how many such units? So two parameters calloc requires. It means what? Here also I am speaking about at this point in time allocate 5 nodes. It becomes again a kind of pseudo-static nature. Okay, I don't want to do that. I don't want to have a predefined thing available. So I'll go for what is called as malloc allocation where I talk about one unit at a time. As and when required, I'll call that and it will allocate memory that is required at that point in time. I don't have any tension about the future. Okay, so simple nature of the malloc makes or forces me to use malloc than the calloc and realloc. I hope this is clear, Praveen, now. Yes, thank you. Now, according to this, I have created my own function called as Createnode. What is the return type of that? It returns a pointer. It returns a pointer. What is that pointer having? Pointer is having address of the first byte among the total number of bytes allocated. Out of the total number of bytes allocated, what it returns a pointer pointing to the first byte of the memory allocated. I hope this is clear for you. That is a return type. Then parameters. I don't have any parameters to supply here for my function that I have written. Guys, you can modify this function as and when required. Okay, when I go up to the point where the modification of these functions can be, I think you can only do on your own. When I go ahead in another 5 or 6 classes, those modifications I'll talk about. Now at this point, simple function I have considered. Createnode is the name of the function which returns me a pointer to the memory allocated by the malloc function called within the Createnode. See, of course, you can very well write malloc function separately also. There is no need of a Createnode function at all. but it has some other things involved in it. When you see it, you will understand. You have to repeat those many number of steps every time. In order to avoid that, I will create a function for that. Then what is the use of this function? It is mainly used for creation of a new node. Empty node it is. Okay. Now just have a look at this. According to this function, how I can write? I will write the name of the function create node with empty opening and closing brackets because there are no parameters. But what is the return type? Please highlight on this. What is the return type? It is the address of the first byte. It means what? It's a pointer. What kind of pointer it is? It is of type struct node star, because the data type with which you have created a node, that data type has to be the return type. Is this clear or no? Please let me know. At every point in time I'll be asking this question because I'm talking step by step. According to the function header that I have talked about, I have written the function header according to the description that I have given. What does the description talks about? Create node is the name of the function and it accepts no parameter, but it returns a pointer to the first byte allocated out of the total number of bytes allocated for a node. So when I talk about a node, I have to have a pointer of type struct node star. Are you getting this or no? Please let me know. Yes, are you getting? Guys, if you don't speak, I cannot proceed. Only Shreya has commented yes. You're getting this. Okay, thank you. Now, this function header is clear for you? I hope so. Now, what I will do, I'll create one local variable by name star ptr, which is the pointer getting returned, which is the pointer getting returned by the create node function. So ptr is the node pointer which will be returned by the create node function. Then who will receive in the main calling function, that we will see later. Right now we will bother about the create node function that we are going to write. Okay, guys, you want me to write this and show, or shall I explain the thing that has been written here? If you want me to write it, I will write it for you. I'll develop this code for you. What do you want? Please let me know. Let me know. I'm waiting for your comments. Okay, if you start the flow from the main, Praveen, before I start the flow from the main, this function is so important. Okay, this function is so important because it is needed for whenever you want to have a creation of a node. Okay, if you want me to explain the code from the main, I will do that, not an issue. Main contains simple function calling, nothing else other than that. Let me just go to main. Okay, there are three choices: insert rare, display, and exit I have taken. And in case 1 I have called insert rare function, display I have called display function, and in case 3 I have called exit. Main is the simplest function that you are going to write, so there is no need of any explanation. Let me start writing this. Okay, um, let's say what all are the things that I've discussed. Create node contains no parameters, but it has a return type. What kind of return type? It's a type, pointer type of type struct node. Okay, so let me just start writing that. Struct node star. Do you write int star for integer pointer? Do you write float star for float pointer? Char star for character pointer? Similarly, this is a pointer pointing to a node. That's why the return type has to be struct node. I hope it is clear for you guys. I think I have explained it 10 times by now. Okay, I've explained it 10 times by now. Now, it doesn't contain any parameters, so I have kept it empty. Now, between the opening and closing brackets, what this create node function must do? Create node function must call a malloc function, okay, and allocate the memories that are required by a node. Required by a node. How a malloc function is written? If you can remember, it will be of this type: ptr. Let me just refresh. Okay, let me just refresh. I think this I have spoken when I was talking about pointers chapter. Okay, I was talking about pointers chapter. I have discussed about this. So anyways, so can anybody tell me what is the format or syntax for malloc? Can anybody tell me? Can you unmute and let me know? Any data type ptr equal to. Yes, can anybody comment? Yes, can I have Anushka unmute, or you can type in, whichever is comfortable for you. But you have to be fast.
Yes, ma'am.
Yeah, Anushka, what should I write for the malloc syntax?
Malloc size
Yeah,
of
malloc. Yes, size of.
size of data type.
Correct. So
Yes,
when
ma'am.
I write something like this, it means what? This is typecasting. I have explained it very well and when I was explaining malloc function. Okay. Now with reference to this, if I want to write it here, how should I write, Anushka? What is the way I need to write? I need to write it like this. Struct node star ptr equal to. Am I right?
Uh,
Yeah. Okay. What should I write next?
ma'am, struct node
Correct. Should I write struct node or struct node star?
star.
Correct. Then
Malloc
malloc.
size of struct node.
Correct. Correct. Thank you. Size of struct node. So what is the meaning of this? When I write like this, struct node star ptr. So what you can do is you can very well separate these two into two different statements. This is what I have done. What I have done? Struct node star ptr. I have declared it first. Then I have used that pointer variable equal to, this is typecasting, malloc bracket size of struct node. Do I need to give here struct node star? Can anybody comment on this? If I give struct node star here, this is talking about pointer size. But when I give only struct node, it is the total size of the node as a whole. Okay, this is how struct node star is differing from struct node. Can anybody tell me quickly what is the number of bytes that is given by struct node? What is the number of bytes given by struct node star respectively? I'm waiting for your comments. Yeah.
Struct node is 4, ma'am, and
Huh?
struct node star is int, so it is
Correct,
2.
Pranav. You're right. You're right. So when I give struct node star, it will allocate only for the pointer. But I require two parts in it. One is info part and the other part is link. So as a whole, I require 4 bytes of memory. That's why I am not afford to give here star. This has to be struct node. But what about here? This is typecasting. It has to be struct node star. Is this okay? Comment, guys. Is this okay? Clear with this? If clear, I'll proceed. See guys, this is so important part of the explanation. Until and unless you understand this, we cannot proceed ahead. So is this okay? So let's proceed ahead. Now what I will do, out of the sometimes it so happen that there may be, okay, there may be the required amount of size of memory is not available sometimes. Okay, just give me 1 minute of time. I will just unlock the meeting. People are waiting. Okay. Okay, now it may so happen that the size of the node of a structure is so big that at that point in time, that much of memory is not available. It may so happen. See, the structure may contain any number of members in it. According to that, the number of bytes required at a time may be 1 lakh. It may be 2 lakhs based on the kind of the node that you have created. The kind of the information that is getting stored may be so big that that much of memory is not available. How do you check with that? So I have a simple condition checking. If pointer equal to null, if it has returned a null, it means what? I cannot allocate those many number of memory locations. Okay, memory cannot be allocated. This is an error message. Okay, you cannot have that much of memory. It returns a null. What is null meaning? I cannot have that much of memory, so you just can proceed ahead. That is the meaning of it. Now otherwise what happens? It has allocated the memory, and who has the starting address of the total allocated memory? Can anybody tell me quickly? If it has allocated the memory, who has the first bytes address? Which variable has the first bytes address? PTR, you are right. So what should I do? I just will do that. I will just inform others, whoever has called this function. I'll inform them that this is the starting address of the total number of memory bytes that are allocated, and I'll return the address of that. How do I do that? Return PTR. So I'll write else return PTR. Is this okay? This is a whole lot of create node function. So every time you have to do all these stuffs, every time. Instead of that, I will write a function for that. I'll write a function for that, and I'll call at every point in time create node function. To have the simplicity, I will create my own user defined function called as create node function. Is this okay? The same thing has been done. I'll just go back to the program that I have written. Just have a look at this. The same thing has been done. Okay, create node is the name of the function. It returns struct node star. That means it returns a pointer containing the address of the first byte of the memory is allocated. Then I have declared a pointer which is a local variable. Then I have called the malloc function. It returns a pointer ptr which holds the first byte's address. I will just check the error if I have. If not, I will return the pointer. Any doubt in the function that I have explained just now? If no doubts, please comment no doubts so that I can proceed. Yes, no doubts? No doubts. Okay, thank you. Praveen has a question. If PTR equal to null denotes last element, therefore no more no man. See, PTR cannot be null. You are just getting confused with the null that I was talking about in the address part of the node and the PTR that is getting allocated here. This PTR receives a null if allotment fails. Memory allotment fails. There, whatever null is there, that I'm writing explicitly, that you will see when I proceed with the program further. That is totally different. This is totally different. Okay, Praveen? Yeah. Now next task is, as Praveen has told me, I have to go through the main. I'll just go back to the main. Okay, let me just go to the main. In the main, guys, you want me to write it again? I will write it again. Okay, so that it becomes much convenient for you to understand the things. Okay, let me write main function. Yeah, in the main function, I have first of all the choice for the kind of operation that you want to perform on the linked list. Okay, so for now I have only two options. One is the insert function at the rear end of the list, and second is display the current content of the linked list, and third exit from all the operations. Okay, when I'm trying to do all these things, I have three options available, and those are called as choices. So I declare a variable my name choice, and I also require a new element to be inserted that need to be read. So two very important variable declaration, one called the choice for asking from the user what operation you want to perform, and second element that is getting inserted. Okay, along with this I need what is called as a variable of type struct node, and this struct node, as pointed in the previous class, you can just see initially first is equal to null. You can just see this part of the explanation that I had done. Initially my linked list has to be of this category. It has to be of this category. What is that? First is equal to null. And what is the data type of the first? Can anybody quickly tell me what is the data type of first? What's the data type of first? Is it only struct? Yes, it is struct node star. Ananya, you are right. It is struct node star. So accordingly, I have to go for what is called as declaration of this first as struct node star. And what is that? I had commented initially when the linked list is empty, first is pointing to null. So accordingly, I will write struct node star first is equal to null. Is this okay? This line of code is okay for you? Okay, these are the different declarations that I require. See, I'm growing the code as and when the requirements are there. Right now, I have assumed that these are the prerequisites for me. Now, as taken previously, I will take an infinite loop. Okay, why this infinite loop is required? Because I have to repeat the operations until the user ends it. Okay, so let me write printf operations on singly linked list. This is merely a heading. Okay, then printf enter 1. Do you want me to have a character input or integer input? What do you want to have? You want to have character input or integer input? Choice. Int. Okay, so then let me go ahead with insert rare for 1, 2 display, 3 for exit. For now, I don't have any other options for now. Okay, then let me have scanf. Sorry, let me write printf enter your choice. These all things are repeated. Okay, then scanf %d, since I have taken integer as the choice, ampersand choice. If character is there, I have told you %c before that give a space. Okay, I have shown you already about that. Then I will supply this choice to the switch. I think probably we have done this many a times. Then I will write case 1. In case 1, let me write printf enter the element to be inserted. Okay guys, before I proceed, do you want me to have any kind of condition checking for overflow? as that of stack and queue? Any overflow condition required here? No. Why not? Why shouldn't? Because it is dynamic allocation, okay, and linked list doesn't have any end limit for the insertion of the nodes. For that reason it is taken like this. Okay, now when you are inserting a new node, okay, let me just proceed ahead like this. When I'm inserting a new node, I have to create a temporary node. This we have discussed previously. Okay, I have to create a temporary node, fill the value that has to be inserted as part of the info part of the node, and then assign this temp node as the new node initially. Then this temp node becomes the first node for the first insertion. Second insertion onwards, temp will go to the rear end of the list. Okay. Now when I'm doing this, when I'm trying to do this, I just have to call at this point of time insert rear function. Okay. Insert rear function. Let me write it as insert underscore rear underscore singly linked list. And when I'm trying to insert at the rear end of the list, initially I should know where my first node is available. Yes or no? At what point or where exactly I have to add my new node. So to do that, in order to do that, I should know where the first node of that particular linked list is available. So how can I get that? I will get that by what is called as the pointer first. Who is having the address of the first node? For address of the first node is contained in a variable, pointer variable called first. And then I require what is called as element that need to be inserted. Okay, let me just glance through this function calling again. What I have written? I have written a function name insert underscore rear underscore singly linked list, which requires from what point in time I have to start searching for the position of the new element. What is the point, starting point? That starting point is passed by what is called as variable first, because first is a pointer which holds the address of the first node of the singly linked list. Okay, we'll come back to this function call again afterwards. And when I try to insert a new function, new value, what is the new element that is getting inserted? That also I require. That's why two parameters are needed here. First parameter talks about the starting address of the first element or the first node of this singly linked list. Then I require the new element that is getting added. So two parameters. What does it return? That we will see later, not now. Okay, at this point, insert rear function I have called, and that insert rear function must create a node, fill the info part of the new node that is created with the element that I have supplied, and then allocate that with the proper position in the linked list. This is the task of insert rear. Okay, I'll just write break. Then for case 2, what is case 2? It is the display. Simply I will call display underscore singly linked list of from where I have to start displaying, from the first node. I don't require anything else other than this. Okay, so accordingly I have written the display function as display underscore singly linked list in bracket first as a parameter, because the point from where I have to start displaying. Then case 3 is what? It is case 3 is exit. I have included already stdlib.h. Any doubt in the main that I have written? Please prompt me if you have any doubt. Guys, it is not 100% correct yet. Please let me know up to the point that I have written any doubt you have. No doubts? Probably you are receiving my packets a bit late today. Okay. We should know the current element. Definitely, yeah, you should know the current element. Okay, definitely, and that's why this element is passed over here. So once I complete writing the program, I will explain with reference to this program again. Okay. Now, I'll just go back to these functions that I'm speaking about now. Insert rare. So I'll just go back to insert rare function. Let me just clear off all this. I'll just clear off everything because I will start writing again. Okay. Now, according to the current function call, insert rare is not returning anything. Okay. So what is the meaning of that? It has void as a return type at this point in time. Then what all are the parameters? What is the first parameter that we are talking about? First. And what is its data type? First data type is struct node star. It is not only struct node, it is struct node star. Are you okay with this? Are you okay with this? Okay. So according to that, I will write the first parameter as struct node star. Let me take the same variable, say first, comma. What is the second parameter? Element is the second parameter. And what is its data type? It is integer. So let me write int e. So according to the function call that is given, I have written the function definition. Okay. According to that. Now, what is the task that need to be done by the insert rare function? First of all, it has to create a node, allot element to the info part of the new node that is created. Okay. Then place that new node at a proper position. Okay. Now in that manner, if I proceed ahead, what is the first task that need to be done? I have to create a new node. Okay. How can I create a new node? Can anybody comment? How can I create a new node? How can I create a new node?
Calling the function.
Correct. Calling the create node function. So I will simply call the create node function. But create node functions return what? It returns a pointer of type struct node star. So obviously, what should be the thing that I need to do? I need to have a local variable, say called temp. And what is its data type? Struct node star temp. What is its data type? Its data type is struct node star because create node returns what? A pointer of type struct node star. So temp equal to create node. I have called this function. What this create node function does? It calls in turn the malloc function, allocates 4 bytes of memory and returns the address of the first byte allocated and getting stored in the variable temp. Now temp is nothing but a pointer pointing to a free node that is getting created. Then next what I need to do? I have to pass this element to the info part of the temporary node that I have created. How can I write that? Programmatically, how can I write that? If I want to allocate element E to the info part of temporary node, what is the way out? Correct. I need to write temp arrow info equal to element. Okay. Now, this temporary node that is created, it is an independent node right now. So what I will do is, I'll just write temp arrow link equal to null. What is the meaning of this? It just creates, I'll just go back to the slideshow. It just creates me a temporary node, something like this, which has 2 parts in it. Info part gets filled with E and this part gets filled with null. I'm doing it explicitly. I hope Praveen, now it is clear for you. This null is different. The null that I was speaking about in malloc function is different. Okay. Now what these 3 lines of code have done? These 3 lines of code have done. Have created a new node and allocated info part with the new element that is getting added and the link part as null, indicating it is an independent node that is existing right now. Have I added to the existing linked list? I'm not added it. Have I added to any linked list? No. This is an independent node containing info part as E and the link part, that is address of the next node, as null. It means what? This is the only node that is available right now. Can anybody tell me, when I call insert rare function for the first time, what is the content of first? If you want me to glance through the program, I'll do that. I'll just go to the function main. Okay. Before calling the function, first is passed. What is the initial value of first? I'll just go back and show you. It is null. Aishwarya, it is not address, it is null. Address, of course, definitely. But what is the address right now? Null. It means what? List is empty. I do not have any element in the linked list. That is the meaning of it. So first is right now null. Okay. Now according to that, when first is null, what I should do? When first is null, it means that the node that is getting created will become the first node. Yes or no? Initially, when first is null, the node that is getting created right now will become the new first node of the linked list that is getting created. So how can I check that? If first equal to null. So what should I do? I should make sure that the temporary node that is getting created becomes the new first node. How can I do that? I will do simply like this. I will write return temp. When I write return temp, there is a return type. When I write return temp, there has to be a return type. What is the return type? What is the type of temp? It is, I'll just go back and check. What is the data type of temp? It is struct node star. Don't call it as struct node. It is struct node star. So according to that, void will become struct node star. Are you getting this step that I have done or no? Please comment quickly, otherwise I'll repeat it. Again, I have to explain. Okay, let me just undo the things. Let this be void again. Okay, so before I write this condition, up to this it is okay. I have created a node. In that info part I have filled with E and the link part of the temporary node filled with null. It means I have created an independent node containing E as the information and it is not pointing to any other node. Okay, with this background, if I want to try to insert this temporary node into an existing linked list, that existing linked list having the first node pointed by a pointer first. Now, when I call this function for the first time, what this first contain? It will contain null. It means I do not have any existing linked list. I do not have any kind of existing linked list. Then it means that the node that is created, that has to be the new first node of the linked list that is getting created. The first time when I call this function, the node that is getting created will become the first ever node of the linked list. So how can I check whether the linked list is empty? It's very simple. I will check whether first is equal to null. If so, then the first has to be overwritten. First has to be overwritten. Now this first contains what? This first contains null. It has to be overwritten. What I will do? I will return the address of temporary node as the address of new first node. So first will receive what? Address of the temporary node. Otherwise, if any other node is there, first will have its own address. So when I want to allocate the address of temporary to the first, what I have to do? I will write return temp. Otherwise, what you can do? First is equal to temp also you can do. Not an issue with that. Now when I write return temp, temp will hold the address of the newly created node and that has to be overwritten in the main with the first. Okay, the temporary node's address has to be overwritten in the first that is available, which is empty initially. So when I write return here, definitely the function must have return type. What should be the return type? The type of the thing that I am returning. What is the data type of temp? It is struct node star. So accordingly, void getting replaced with struct node star. Up to this point, any doubt? I hope there are no doubts. So when I return this temp, there has to be receiving variable. So what I will do, I'll just go back and overwrite this with first is equal to. What's happening? First getting overwritten for the first time. When I'm trying to insert a new node for the first time, only then this overwriting will happen. Further of the things, it will never happen. Any doubt? Anushka, is it okay? Yes. Even you can overwrite in the function. First is equal to temp. If you do, it will do. But I don't want to overwrite. I want to overwrite it in the main. That's why I have returned it. Okay. I will stop at this point and the continuation will be done by the next class, tomorrow's class. Tomorrow 9 o'clock, I will be continuing this. Okay. Okay, if we are inserting nth element, how do we do that? We will see it tomorrow, Praveen. Okay. It's a top secret. I'll not leave that secret today. Okay, yeah. So I'll be completing this insert function by tomorrow. So join back at 9 o'clock. Thank you all.